All right, welcome to sections 8.5 and 8.7. So we're going to do 8.5 first, preparing for calculus. So basically what this is just a review of algebra skills that you will definitely need for calculus and also for pre-calculus. Let's see. So first example here, simplify expressions. The following expression represents the derivative of a function. So derivative of a function is something you'll learn in calculus. Simplify the expression by multiplying to remove parentheses and combining like terms. So most of these problems are just going to be exercise in PEMDAS, all right, your order of operations. All right, so for this first one here, we're going to distribute the 2x, right? We're going to multiply the 2x here and here. Okay, so, and don't forget your equal signs here. So 2x times x cubed would be 2x to the fourth. And then 2x times negative 3x, watch out for those negative signs, would be negative 6x squared. Okay, and then plus. And then what we're going to do here is we have two sets of parentheses, right? So what we're going to do when we have to multiply two sets of parentheses like that is we're going to use our favorite four-letter F word in math, right? FOIL, right? No, not the other one. FOIL. All right, so first, outside, inside, last. It tells you the order. You don't actually have to do it in that order, but it just helps you not miss any of the pieces, right? So first times, oops, that's not first. There we go. First times first. O for outside, I for inside, and L for last times last. Okay? All right, so let's do that. So we're going to do x squared plus 3x squared, which is 3x to the fourth, minus 3x squared. That's our outside. Inside is negative 3x squared, and last times last is positive 3. Okay? The next step, of course, is we're going to combine like terms. So we notice we have a couple terms with x to the fourth. So we have 2x to the fourth plus 3x to the fourth. So that makes 5x to the fourths. Then we have some x squareds, right? There's an x squared, and x squared. All right, so we have negative 6x squared minus 3x squared minus 3x squared. So that should be negative 12x squared. All right, and then we have our constant term over here, plus 3, and there we go. Okay, so that's all they're asking us to do here. All right, next example. In calculus, the derivative of f of x is denoted by this notation here. That little mark right there is called prime. So this is f prime of x. And the value of the derivative is at a equals a is denoted f prime of a. All right, just simply means change the variable, right? Instead of an x, it's going to be an a. If f prime of x equals 3x squared minus 4x plus 2, they want us to find f prime of negative 1 and f prime of 3. So it works just like you've done before in your function notation. This simply means take the function, plug in a negative 1 wherever you see an x. Use parentheses appropriately. And this one here, plug in a 3 wherever you see an x. Use parentheses appropriately, right? Okay, so let's do those here. So we're going to do f prime of negative 1. So we're going to replace all the x's with a negative 1. Notice my use of parentheses. Okay, and equal signs here. So let's see, 3 times negative 1 squared. So remember, PEMDAS says do the exponents first, right? Parentheses, then exponents, then multiply. So negative 1 squared is positive 1, times 3 is positive 3. Then we have negative 4 times negative 1, which is positive 4, and then plus 2. All right, so what is that, 7, 8, 9, looks like. There we go. So f prime of negative 1 equals 9. All right, and then we'll do f prime of 3. Same thing, plug in a 3 wherever you see an x. Use parentheses appropriately. There we go. So PEMDAS says do the 3 squared first, right? So 3 times 3 is 9. times that 3 on the outside is 27. Negative 4 times 3 is negative 12. Plus 2, so that should be 17, right? There we go. All done. All right, next example. Slope of a tangent line. Calculus can be used to find the slope of the tangent to a curve. This will make a lot more sense in calculus, I promise, but for now it's what we're going to work with. So let's see, slope of the tangent to the curve y equals f of x at x equals a is f prime of a. It's just another way to say the derivative. So there's our derivative function. Find the slope at the tangent of the tangent at x equals 2. All right. In other words, they want f prime of 2. Okay? Same thing we just did, right? Plug a 2 in, parentheses. So let's see, 4 times 2 cubed minus 3 times 2 squared plus 1. All right, so 2 to the third, 2 times 2 is 4, times 2 is 8, times 4 is 32. Right here, 2 times 2 is 4, times negative 3 is negative 12, plus 1. And if I did my math correctly, that should add up to 21. Okay. All right, so I know these are easy, but it's good, really good practice. All right, calculus can be used to find the slope of a tangent to a curve. We said that before, but it's good to keep hearing it. And then we can write the equation of the tangent line. So they're saying here, if the slope of the tangent line to the graph f of x equals x squared at the point 1, 1 is 2. So in other words, 2 is the slope and 1, 1 is an xy coordinate. Write the equation of this line. Well, this is what you've done before, and there's multiple ways to do it. You could use y equals mx plus b, or you could use y minus y1 equals m times x, x minus x1, right? So either one. I personally choose to use y equals mx plus b. Excuse me. All right, so here we go. So I'm going to use y equals mx plus b. So I have an x, a y, and an m. So I'm going to plug in. So y is 1, slope is 2, x is 1, b is unknown. Okay? Excuse me for a second. It's super windy out there. There we go. A little stuffy. All right. Anyway, 1 equals 2 plus b. So we'll subtract 2. So b equals negative 1. All right, and then we want the equation. So y equals mx plus b. Well, we know that m is 2 and b is negative 1. And there you go. That's the equation of the tangent line to that graph at that point with a slope of 2. All right? Okay, so don't worry too much about all the calculus stuff I'm saying. Actually, don't worry about it at all. Understand the algebra. That's the important stuff. All right, the next one here is the difference quotient. You're going to see this a ton in pre-calculus and calculus. So we're going to work with it, right? So this is called the difference quotient, right? Difference because we're subtracting. Quotient means fraction. Okay, so reduce this fraction as long as h is non-zero. Don't worry, that'll make more sense in pre-calc and calculus, but you just can't have a 0 in the denominator, right? So we can't have an h being 0. All right, so again, we're going to use PEMDAS. We're going to simplify the numerator, the top, as much as possible, and then divide through by h, okay? So we're going to distribute here. So we get this is equal to 2x plus 2h plus that 1 right there, minus, and watch your parentheses. Well, actually, we can distribute that negative sign, right? So that'd be minus 2x minus 1 all over h. All right, let's see. So notice what we have here. We have 2x minus 2x. Perfect, they're gone, right? And then we have positive 1 minus 1. They're gone. So all that's left is 2h over h, and that's really nice because h over h is 1. So there we go. This is equal to 2. All right, an important calculation in calculus is the evaluation of the difference quotient. So that's what we're just working with. This is the difference quotient. So what we're practicing here is function notation. F of x plus h means in your function, wherever you see an x, replace it with x plus h with parentheses appropriately. Okay? So that's what we're going to do here. So this is the function we're working with, and we're going to plug it in and simplify it with the difference quotient. Okay? So f of x plus h minus f of x all over h, using this function right here, means 3 x plus h, right? We're replacing x with x plus h plus 2. Now be careful here. Minus f of x. This is f of x, right? So parentheses 3x plus 2 all over h. All right, we're going to do pretty much what we did in the last problem, right? Distribute the 3 here, distribute the negative sign there, simplify. All right, so we get 3x plus 3h. Don't forget that plus 2 minus 3x minus 2 all over h. And every time you do this, if you do it correctly, just like on the last one here, notice you should end up with your numerator only having h terms in it. If you have x's left or constants with no h, something's wrong, you got to recalculate. You should always end up with only things attached to an h in your numerator if you do this right. And this one works, right? 3x minus 3x, 2 minus 2. All we're left with is 3h over h. The h's reduce away. Don't say cancel, they reduce away. And your answer is 3. Okay? All right, not too bad, right? All right. Now, a lot of times what you're going to do in calculus is you're going to find that derivative function and then set it equal to 0 and solve. So you've done this before. It's no different than the process you use for finding the zeros, finding the x-intercepts, etc. All right, so we're just going to take the derivative, this function here. So in this case, 3x minus 6, and set it equal to 0 and solve. Okay? Nice and easy. We'll add 6 to both sides. Divide by 3 on both sides. X equals, so that'd be 6 over 3, which is 2. And there we go. Okay? Same with part B here. We're going to take the function, set it equal to 0. So 8x minus 4 equals 0. So we'll add 4 and divide by 8, which is 1/2. Okay? Okay. Another thing you're going to have to do in calculus is rewrite radicals. Calculus does not work too well, or the methods we have don't work too well with radicals, with roots. So we got to modify them. All right. So a little reminder here. So a root is a fraction exponent. Okay? In other words, we would rewrite this as 3 times x to the 4th to the 1/3 power. Okay? All right, 3 times x to the 4th to the 1/3 power. Notice my use of parentheses here. Now remember the rules of exponents. When you have an exponent outside of parentheses and one inside the parentheses like this, you multiply, right? So that'd be 3 times x to the 4/3 power. And there we go. Okay, we converted into exponential form. Okay, part B, similar, right? So remember when you have a square root symbol, technically there's a 2 there, all right? We don't write it but that's what's there. So this is y equals 2x times x to the 1/2 power. Okay. Now remember, when we're multiplying the same bases, we add the exponents. So technically speaking, there's a 1 exponent right there, right? So 1 plus 1/2 is 1.5, or the way we'd normally write it here, 2x to the 3/2 power. Okay, we just added those two exponents. Okay, moving on. Again, finding where the derivative is 0 is an important skill in calculus. So find where f prime of x equals 0 if this is your derivative. So in other words, we just take the function, set it equal to 0, factor, solve. Okay, so 3x squared plus x minus 2 equals 0. All right, so we're going to set up our parentheses here. So it's going to be 3x and an x. And then we have a negative 2 out here, so we're going to multiply a 1 times 2. We'll play with the signs in a minute. So let's see. Put the 2 here and the 1 here. Let's try it. May or may not work. Sometimes you're wrong. Try a different method, or switch the order. Okay? So we want our middle term to be positive 1, right? So that means we should make, let's see. Let's see if that works, right? So 3x times x is 3x squared. So that works. Outer is 3x. Minus 2x is 1x. So that worked, right? And then negative 2 times 1 is negative 2. So there we go. And then we use our 0 factor property. In other words, we take, excuse me, we take each set of parentheses and set it equal to 0 and solve. Okay, so working with this one first, we'll add 2 and divide by 3. And with this one here, oh, that's not what I wanted. With this one here, we'll subtract 1. And there we go. All right, keep going here. Simplify by factoring. So factoring means, factoring out, dividing out a common factor. So what we can see already right there is a common factor, 6x minus 1. Okay, but we got to work with this. So inside the square parentheses here, we notice we have a 2 times 6, right? Times that x on the outside, this would be equal to 12x times 6x minus 1. We're going to leave that parentheses because we know we're going to be able to factor that parentheses out. 6x minus 1 squared. Okay, so we're going to factor out a 6x minus 1. So 6x minus 1. And then we're going to say, well, what's left if we divide this and this separately, of course, by 6x minus 1. So the first one, we would only be left with a 12x. And the second one, since it's squared, it would be just plus 6x minus 1. And we'll simplify that. So we get 6x minus 1. 12x plus 6 is 18x. And then minus 1. And there we go. Okay. Now notice it says simplify, not solve. Okay, simplify is when you do not have equal signs. Solve is when you do have equal signs. All right, let's see. Example function decomposition. To decompose means take it apart, right? So find two functions f and g such that their composition is f of g of x equals this function. In other words, f of g means take the g function and plug it in to the f function wherever you see an x. So the easiest way to do a problem like this, especially with the radical, it's actually pretty easy. Whatever's under the radical, that's your g function. So g of x equals x squared plus 1. And f of x, if we took that out and just put an x under there, f of x would be radical x. Okay? So again, notice what we did. We take this, right, g function, plug it into the f function where you see an x, and that's what we get. Make sense? Hopefully? Okay. All right, let's see. More stuff for calculus. This is towards the end of Calc 1. You'll need this skill. Rewrite the function using negative exponents. Okay, so remember, a negative exponent flips the fraction, or flips that part of the fraction. So we're going to say f of x equals, so we have that 4 up there. But we want this to go up to the top, right? So that means it's going to be x to the negative 2 power. Okay? Plus 3, again, we want the x to go up to the top. So that'll be x to the negative 1. And minus 2x, so there we go. Okay? There we go. And then you'll see in calculus it'll be easier to work with if you do that. Okay, next thing, logarithmic properties. I believe we covered that in this class before. You definitely got to know your log rules, especially if you're going into pre-calc or calculus or anything beyond this class. So remember, when you're multiplying, you expand it out with addition. Okay, so this will be log of x squared plus, because right there's the multiplication, plus log of 2x plus 3 squared. Okay, and then we have another rule of logarithms that allows us to take these exponents and bring them out to the front as multiplication. All right, so we will get 2 times log of x, right? That 2 went to the front there. Same thing with the other exponent of 2. Oops, sorry, plus 2 log of 2x plus 3. And there you go. And that's a properly expanded logarithm. Okay, make sure you practice those. Very similar here. So now we're using, remember the ln means natural logarithm, log base e. All right, so now we're dividing. So remember, division becomes subtraction. In other words, natural log of the top, so 2x minus 4 square root, minus natural log of 3x plus 1. All right, always top minus bottom, always. Now we can, whoops, what happened there? There we go. We can rewrite this for fun. So natural log 2x minus 4 to the 1/2 power minus natural log of 3x plus 1. And again, these are skills for calculus. You'll see why this is important in calculus. So that 1/2 can come to the front because of the rules of logarithms. So we'll say 1/2 natural log 2x minus 4 minus natural log 3x plus 1. And finally, there you go. Logarithms expanded out. All right. Almost done with this section here. So another one. If the derivative equals 0, find where f prime of x equals 0 if that's your function. So we take the function 2x to the third minus 2x and set it equal to 0. All right, so we can see right away we have a 2 in common, right? 2x minus 2x there. So what we can do is divide by 2 on both sides. Make life easy for ourselves. Work smarter, not harder. Okay, but remember, doing this means we have 2 fractions here. Don't think it's just one fraction. It's 2 fractions. Okay, so 2x cubed over 2 is x cubed, minus 2x over 2 is x, and 0 over 2 is 0. Okay, now we notice here's our 2 terms, right? We notice they have an x in common, so we factor out an x. Factor out means divide out, so that means x squared minus 1, and this is all still equal to 0. And again, our 0 factor property, take each of the factors, set them equal to 0 separately, and solve. Well, that one's easy, right? X equals 0. Then x squared minus 1 equals 0. All right. And then, let's see, so we'll add 1 to both sides. Then to solve this, to get rid of that square, we need to square root both sides. So square root of x squared is x, but remember, when you square root both sides, remember you have to do that plus or minus thing. Okay? So plus or minus 1. Okay, so there we go. We're good on this section here. We're going to finish up the semester with 8.7 here. All right, so just some conic sections, circles, and parabolas. These are things you should know. Again, it'll help you in pre-calc and calculus and beyond. All right, so the distance formula, you've seen this before. I'm sure you've worked with it in geometry. So the distance between 2 points, right? So if they give you 2 coordinate points, x, comma, y, you plug into this formula, you get the distance between those 2 points. Okay, so here we go. Find the distance from negative 3, comma 2 to 1, comma negative 4. Plug into this formula. So distance equals, all right, so it doesn't matter which one you call x1, x2, etc., but you need to be consistent, right? So we'll just simply say x1, y1, x2, y2. So follow that order. So x2 minus x1 is 1 minus negative 3, and notice we square that, plus, then it's going to be y2, which is negative 4, minus y1 squared, and we square root the whole thing. All right, so PEMDAS, work with your inside your parentheses first, then the exponents, then add, and then square root. Okay, so let's see, this will be 4 squared plus, this will be negative 6 squared. Okay, and then this will be 16 plus 36, still all under the square root there, which is the square root of 52. Now remember, you should break these up. You should simplify these as much as possible. 52 can be rewritten as 4 times 13. Okay? Rules of radicals says we can break this into 2 separate radicals and multiply together. So rad 4 times rad 13. Well, the square root of 4 is 2. And there you go. So the distance between those 2 points is 2 radical 13. Okay? Then again, from geometry, your midpoint formula. So again, if you're given 2 coordinate points, this is how you find the midpoint, right? Midpoint means halfway, right? So notice what we're doing. We're adding the 2 x's up and dividing by 2. You're finding an average. That's what you're doing, okay? Same thing with the y's. Okay, so midpoint, so we write it out like this. So again, we'll do this x1, y1, x2, y2. All right, x1 plus x2, negative 3 plus 1 over 2, comma. Y1 plus y2, so 2 plus negative 4 over 2. All right, and we simplify. Negative 3 plus 1 is negative 2 over 2. 2 minus 4 is negative 2 over 2. Well, that's convenient, right? Both of these reduce to negative 1. And there's your midpoint. Okay. All right, almost done. Hanging on. Standard form of the equation of a circle. So that's important. You should know that formula right there. X minus h squared plus y minus k squared equals r squared, where the center is hk and the radius is r. Okay? All right, so let's use that formula. Write the equation of a circle with center at negative 3, 4 and a radius 5. So remember, this is h, this is k, and this is r. So we just plug into that formula, nice and easy. X minus, so minus, well, here, let me write it out. Minus negative 3, right? Quantity squared, plus y minus k, which is 4 squared, equals 5 squared. So we'll clean this up. We'll do x plus 3 squared plus y minus 4 squared equals 25. Okay, and there you go. That's the equation of that circle with a center of negative 3, 4 and a radius of 5. All right, so write the equation of a circle centered at 3, negative 1, passing through 4, 6. Okay, so in other words, 4, 6 is on the outer edge of the circle somewhere. So we need the radius, right? We've got the center, so we already know h and k, but we need to know that radius, right? In other words, the distance between the center and the edge of the circle. So first we use the distance formula with these 2 points, okay? So we can do 3 minus 4 squared plus negative 1 plus 6 quantity squared, square root it. 3 minus 4 is negative 1 squared. Negative 1 plus 6 is 5 squared, square root. So negative 1 squared is 1, plus radical 5 is 25. Oops, 25. So this equals the square root of 26. So 26 is 2 times 13, so you're not going to gain anything by simplifying that radical. So this is r, okay? We have h, k, and r, right? So we write out the formula. X minus h is 3 squared plus y minus k, so minus negative 1 is plus 1 squared equals, and think about it, radical 26 squared. If you square a square root, you get the number that's underneath, right? And there you go. There's your formula. Okay, well, thank you for a great semester. I know it was a little rough for all of us. Obviously, 2020, whew, what a mess. Hopefully January starts things a lot better off for all of us. All right, so happy holidays and all that good stuff. Best of luck to you all. Take care.